Okay, let us compute the information gain. Oh. Let us first implement the functionality of compute entropy. Compute entropy for a variable that has only categorical values is relatively straightforward. Compute, let's implement that right now. Entropy, let's call the variable y. So y is a group of values. There's a safeguard over definition of the y. If there is no actual distribution is a certain value, or y isn't something that is aggregated object, it just return 0. And now let's assume y is some series, some a vector of value that's maintained by the pandas library. Pandas provides us a very convenient functionality that it can count the number of occurrence of unique values, and also it can automatically convert this presence, the word counting or the number of appearance into frequency. So let us have a look at an example. Say if we are interested in our target value play, so we can use the functionality of value count for the play. Now it has yes for 9 times and no for 3 times. Well, if we say normalize to be true, it gives us 0.75 and 0.25 respectively. Very convenient. Also, we can use the return value of this function in 2 ways. We will see that later. For now, let us just copy this. So we will use y's value counts. Let the normalize to be true, and we will use numpy. We'll convert that into a numpy array. Therefore, it facilitates the computation of the entropy. That is the frequency to be this. And recall that the entropy's equation is this. You need to do for every value. So if the frequency of the value is fi, we need to calculate the logarithm of fi based on 2. Actually, we need to calculate the inverse of this is a frequency, and that is negative log 2 fi, and this is multiplied by fi itself. So we can create 2 arrays. For one array, we have this log 2 f2 log 2 f3, so on and so forth, and here is f1 f2, so on and so forth. So we then have a dot product of these 2 arrays and take the sum. And this is precisely the functionality provided by NumPy. Very convenient. Just need to, it's so convenient that I just return the computed entropy without introducing more intermediate variables. Frequency. Now this times this multiplication symbol is a loaded symbol. It means element multiplication of each elements of the 2 arrays, numpy.log2, the frequency. Because there is a possibility of some frequency to be 0, and you take the log of the 0, you get a non-defined value, which is not what we want. So we safeguard this in using a very small number. This will create small errors, but it's insignificant and prevents the algorithm go completely wrong when there are 0 frequencies. Okay. So using the compute entropy functionality, we now is ready to define the compute information gain. Samples, feature, and target. The feature is with means attribute. This means with respect to what. Let's just call attribute to avoid confusion. With respect to what attribute we want to split the samples. So let's get the entropy, the original entropy of the target distribution. That are values. Let it to be samples, feature, value, normalize. Oh, sorry. Here, oh, forgive me. I forgot to. Okay. The signature of the function are 3 parts. The sample, this is the data frame, the attribute according to which we want to split the data set, and the target. Here we just use the same functionality, and it returns actually a loaded object. We can use for loops to iterate over this object. Let us see. Unique value is this, and if we use for loops to reiterate that, we will have this unique values. Let's see what we have. Sorry, we should use a wrapped version of this object. It's called iter items, because this object is maintained by data frame. So we have this. Sorry. Let's be iter. Sorry, 8 items. Be here. Now look, in each iteration of the loop, we will have, let's print something, make some noise, so we are sure that we are in different loops. So in each of the iteration, we will have access to the value itself and the corresponding frequency, which makes super convenient for us to compute the entropy of the subgroups. So for wait and fr in values dot iter items, that's a sub entropy compute entropy. Let's call compute entropy using the corresponding subgroups of target samples, and we use the index of samples attribute is this corresponding value, and these subgroups target. So if you don't make good sense of this construction, let's see another example. Say the F outlook is sunny, and we use this to index df itself. Then we will select all the rows that the outlook is sunny. Okay, and we then take the play of this subgroup. Okay, this is what we are doing here. We want to calculate the corresponding the entropy of the corresponding subgroup. So this is subgroup entropy, and let us split have a split entropy initialized at 0, and we accumulate the split entropy using the frequency times the subgroup entropy. Okay, and the total entropy is compute entropy, the sample target value, and we will return the total entropy subtracted with the split entropy subtracted from it. So hopefully that gives us the useful definition of the functionalities, and this is useful tree building functionality. And also I have prepared another function which I will not elaborate here. I just copy from my repository. This is a pretty print function that does no functionality but printing out the decision making internal decision making procedure in a decision tree, which makes it more clearer for us to investigate what we have built. Okay, we don't need this anymore. So let's see if we need some we need to do some debug. So what we'll do is to create a tree ID 3. And we will let the t to fit to our data frame with the target of play, and then we will call t is root pretty print. Let's see what happens. We got some interesting bug. Okay, just a typo. Let's go up, fix it, re-execute the cell, and let's go another issue. Okay, I have used the feature, but now we need to convert that into attribute. Okay. TTR, redo this. Oh, it seems that we are processing, but we still have some small issue. Tree node does not have any. Well, I assume this is because when I copy here, I may have messed up the indentation. Let us re-indent the function and see if it works. Oh, it seems to be working. Sorry. Pretty print dot. Uh-oh. Okay, after re-indentation, the pretty print seems to be working. Let's print out. Yes. Well, look, the decision-making process of the tree is like when the humidity is high, then it looks at when the outlook. When the outlook is sunny, then not playing. When the outlook is overcast, it's yes. When the outlook is rainy, yes. When the humidity is normal, it's just a yes. So it seems to be working. And anyway, I'm sure there are a lot of details I haven't touched. Maybe there are some potential issues we haven't time to test it. But that shows the general concept of implementing this procedure of building trees by looking at information gain of individual attributes and split the samples and go into the subtrees and do this process recursively and eventually build a data structure out of it. We haven't, of course, implemented the prediction functionality of the tree, and the interface is a little bit funny because now we are giving the tree a large table and tells the tree which column of the table is the target function. This is different from the standard interface that we give the tree building the observable the data attributes and give it corresponding vector of target values, but this can be manipulated by yourself. Okay,